Okay, so today we're going to be looking at section 6.1, Composition of Functions. It's going to be very helpful for us to look at some of the definitions and terms before we start working the problems because it kind of jumps in and I want you to kind of see where we're coming from. So, composition of function, the definition is here. It gives you the notation, is denoted by this f of g. That's what it's read as f composed with g, f of g. And when you see this notation, you're probably familiar with the distributive property, but that's not what's happening here. So that little O symbol looks like a degree sign, really small. We're not multiplying here. That's composition. So what that means is you're going to take one function and plug it in for the other. So f is your outside function and g is your inside function. So this is a better way of seeing that as far as notation. So if you see f composed with g of x or f of g of x, that means you're going to take one equation and plug it into the other. And then we'll see some different examples. We'll be finding domain and range and different things like that. So here is one such example. I'll kind of walk you through it. F of g of 1. Now before you can do this, they have to give you what f and g are. So here at the top we have f is 2x squared minus 3, and then we have g is 4x. So since it's f and then g, we're going to be taking g, which is the 4x, and plugging it in to the f equation. We're going to be replacing every x with 4x. So this 4x is going to get replaced in the position where this x is for every x that was in f. So right here, they're showing you the difference. F of g of 1. What they do is they plug in 1 to the g equation. So it's 4 times 1. Right here, they plug in 1, so 4 times 1. Now they replace this 4 where g of 1 was. So now we're looking for f of 4. It's just double plug in. So everywhere we have an x in this equation, we're plugging in 4. So they do 4 squared times 2 minus 3, they get 29. So f of g of 1 ends up being 29. And that's what's going on. Kind of hard to get, but we'll do it in practice and you'll begin to see it a little bit better. They can rearrange them. So this one means g of f. We'll plug in f to g this time. And it's kind of talking about domains as you go. So kind of remember what domain and range were. So we look at our domain as if we have any fractions, square roots, or logarithms, we will have restrictions. But if we don't, then we will have all real numbers. And they're saying that here domain is all real numbers. We don't have any of those scenarios. So we will also begin to work backwards. So given two functions have been put together, we want you to be able to decompose them or take them apart. So that part should be coming up here. Decomposition of functions, where are you at? Oh, right there. I just passed it up. So usually this is finding composition components. I was looking for decomposition. So we have f and g are separate functions. You're told that f of g is equal to h. That's the generic symbol that we use. So we have this function h of x equals this expression. And we want to figure out what equations did we use to put these together. What was f, what was g? There are multiple ways of writing this. You will see several of them. What I normally find is the easiest is to look for an outside function. So I see parentheses and I see something raised to the 50th power. So naturally I'll just replace all of this with an x to the 50th power. That's one of the easiest things to do. Look for an outside function and then let the other one be the inside function. So the outer function is x to the 50th. That's what they're doing here. F of x is x to the 50th. And then the inside function is x squared plus 1, so we let the other equation, g of x, equals the x squared plus 1. So that when I take g of x and I plug it in for x right here, you get this. Now, that's not the only way to do it, but that's one that I find to be the most simple. I think they actually show other methods down here as an alternative method. They could have x squared plus 1 to the 25th. And what did they do? They let f of x equals x squared, and they let g of x equals to the 25th. So a power squared 2 raised to a power 25, you multiply those and you get 50. This is what's happening here. You have this inside 25th power squared, 25 times 2, you get 50. So there's two ways that they've shown how to write it, but there are more. There's probably an infinite number of ways you can express these, but this is also something that we will be looking at. So you have composition. We will try to break it down and go backwards. And then other than that, we will be finding domain and range. We'll probably see some graphics and try to find composition of functions from graphics as well. But other than that, we'll go ahead and jump into MyMathLab.